In the western Pacific Ocean lies the deepest scar on Earth's crust, the Mariana Trench. Plunging nearly 36,000 feet into absolute darkness, its lowest point, known as the Challenger Deep, is so profound that if Mount Everest were placed at the bottom, its peak would still be covered by more than 2 kilometers of water. This extreme abyss constitutes the Hadal Zone, named after Hades, the ancient Greek god of the underworld, representing one of the most hostile environments on our planet. At the bottom of the trench, the weight of the water column overhead exerts an astounding pressure of more than 1,000 bars, or 15,000 pounds per square inch. This is roughly equivalent to having 50 jumbo jets stacked directly on top of a single human body. Under this extreme force, conventional submersibles would be instantly crushed like soda cans, and water temperature hovers just above freezing, between 1 and 4 degrees Celsius. Human exploration of the trench began in January 1960, when Swiss oceanographer Jacques Picard and Navy Lieutenant Don Walsh descended inside the heavily armored bathyscaphe Trieste. For decades, it was believed that nothing complex could survive such brutal conditions. In 2012, filmmaker and explorer James Cameron piloted the Deep-Sea Challenger on a record-breaking solo dive, returning with high-definition footage and scientific core samples from the trench floor. Despite total darkness and crushing pressure, the Hadal Zone is home to an extraordinary ecosystem of specialized organisms. The Mariana snailfish thrives deeper than any other known vertebrate, surviving at depths exceeding 8,000 meters. These animals possess gelatinous, translucent bodies lacking conventional bones and rely on organic compounds called piezolites, which prevent their cellular membranes and proteins from being crushed by the intense pressure. Along the trench walls, tectonic plate subduction fuels volcanic hydrothermal chimneys known as black smokers, which belch superheated mineral-rich fluid at temperatures exceeding 400 degrees Celsius. In the absence of sunlight, primary production does not rely on photosynthesis. Instead, extremophile bacteria utilize chemosynthesis, converting toxic hydrogen sulfide into organic energy and supporting thriving colonies of giant tubeworms, blind shrimp, and crabs. Many astrobiologists and geochemists believe that deep-sea hydrothermal vents may have served as the exact incubator where life first originated on Earth 4 billion years ago. The continuous flow of mineral catalysts, thermal energy, and organic molecules provides a compelling template for abiogenesis. These discoveries also suggest that life could exist today within the subsurface oceans of icy moons like Jupiter's Europa and Saturn's Enceladus. Shockingly, the deepest realm on Earth is no longer untouched by human civilization. Recent expeditions have discovered synthetic microplastics and discarded waste inside the digestive tracts of crustaceans living 11,000 meters deep. Because deep ocean trenches act as natural sediment sinks, non-biodegradable pollutants accumulate rapidly, threatening organisms that have evolved in undisturbed isolation for millions of years. We possess better topographical maps of the surfaces of Mars and Venus than of our own planet's ocean floor. With 95% of the global abyss still completely unexplored, the Mariana Trench reminds us that the greatest frontier of discovery is right here on Earth. What aspect of the deep sea fascinates you most? Drop your perspective in the comments below, and don't forget to subscribe for more Deep Sea Chronicles.